I've done 3 of these webinars. The first 2 were on selection if statements, and then we took a look at variables, which often cause a lot of confusion for teachers as well. And this one is really kind of where it's all leading to, the idea of complexity. And, I always like to start these by thinking, what are we talking about with complexity? And actually, complexity for me is something like this watch. It's where you've got lots of different pieces that all connect to each other and work together to make something, useful, I suppose. And I talk with the children about how if you've just got 2 Lego bricks, what can you do with that? How many different things can you make? And the answer is really not many. You can make a pair of steps or, simple things like that. But if you get more pieces, like a whole bunch of Lego here, then actually there's lots more possibilities. So if we want to be creative and create things, impressive things and useful things, we need to have this idea about how to put lots of different pieces together and understand how they work. And that's kind of what complexity is for me, really. Now, as I go through the examples here, I was having a think, ideas or strategies to simplify the complex. And this is to help children understand it and teachers as well. So, if you're ever in the situation of doing some CPD or a staff meeting in the school on it, these still apply just as much to adults as they do to children. So as we go through the pieces, I'm going to be trying to model these. It's getting to know the parts. I always think it's good to look in design mode to begin with, to get to know, actually, what's the scene here? What's going to be on the screen while this code is running? Then read through the code, just the left-hand side blocks only, to get an idea of the triggers that make things happen. And then also this idea, I find lots of children, especially when they're just starting with coding, they really struggle with this idea that commands trigger other commands that are nested underneath them. So for example here, this little screenshot I've got at the bottom here, when you click the trout moves left. Now, because the trout is tucked in underneath this and indented or nested as we call it, the trout is never going to go left unless we actually click on the trout to trigger it. And that in itself is a relationship between 2 blocks of code. One of them makes the other happen. So you've got this relationship, you've got 2 pieces and they are connected in a way which is a very first sort of idea of complexity, because it's a relationship between 2 parts. And most children get that quite easily, the idea, I click something and it makes something else happen. Great. And they'll all get that quite simply. And that kind of thing is happening in the year 1 and 2 coding curriculum. But what happens when you get to Key Stage 2 is you get things like this happening, where you've got something tucked under something else and then tucked under something else again. And this idea of something, the timer here, every 5 seconds will trigger the if check. And then the if check, if day does equal 0, will set the day to 1. Now, for the day, that variable day set to 1, for that to happen, 2 preconditions have got to be in place. You've got to have the timer firing on its every 5 seconds and the day equal to 0. And then so it's this idea of one thing being tucked in and then tucked under again, which gets a little bit abstract, and they can struggle with that. So we'll look at some examples of that as well. I think the biggest thing which I struggle with children to encourage them, sort of my biggest battle in the computing suite really, is getting them to focus and to have this thing called attention to detail, which really, I don't know, maybe you're luckier than I am, but I suspect it's a kind of general thing with kids up and down the country all over. Attention to detail isn't something that comes naturally to them, but in coding it really matters. And then lastly, taking things one step at a time, and also saying things in everyday English. So, translate this code into everyday sort of English. So let's take a look at some examples, and we'll try and put those into practice. I wanted to say as well that in the computing scheme of work, we've been using this idea of PRIM, which is predict, run, investigate, modify, and make. And there's a kind of progression built into that, in terms of confidence with a concept. And to begin with, getting children to predict what code will do. It's just reading code or learning to understand code. It's a bit like a sort of reading comprehension, but using code, isn't it? And that P is sort of where it all starts, really. And if they get that, then they are able to mod it, to make their own programs and design them using the ideas. So definitely starting with reading code and moving on to making code. Let's look at reading some code. So simple things like this. I think I already mentioned, your basic ideas of complexity come with things like this. So we've got 3 blocks at the top here, linked together with clown. Sorry, before I start that, I did say look at design mode. So click into design mode, and I always encourage them to have a look. What's on the screen? What are we dealing with here? So I can see I've got my background here, and I've got 3 fish in front of it. I've got clownfish, tuna, and trout, I think it is. So when I exit design mode, I'm thinking, okay, so what's happening with those 3 objects on the screen? I've got to sort of bear that in mind. The next thing I do was I was talking about how if you read through the code, looking at the left-hand side blocks first to get an idea of triggers that make things happen. So reading through this, I would just look at it and say, okay, when I click the clownfish, something's going to happen. I'm not going to bother about going into the detail now. When I click the trout, something's going to happen. So I'm just getting this idea about how does the user make things happen in the program? What sets things off? And in this case, it's just the clown clicking things. So I can read through it in a bit more detail and perhaps try that idea of looking at it in everyday English and just saying things like, when I click the clownfish is going to move right and the tuna fish is going to move left. And a really important thing for the children to understand here is that word and. And I said the tuna fish is going to move left because the tuna fish is tucked in or nested inside this when clicked command with the clownfish. So, it's worth talking to the children. How many commands are nested inside the clownfish being clicked? And making sure they understand that 2 commands are nested in there. So 2 different things will happen when we click the clownfish. Because what I find is that children will often get a little bit confused. And if I drag this tuna left here and just say maybe get rid of the trout altogether, you'll end up with children quite often saying things like, I'll ask them, what happens when I click the clownfish? And they'll say, oh, the clownfish will move right and the tuna fish will go left. And that's obviously not the case because the tuna fish is going to go left on its own accord. It's a sort of left-hand side command. And when we press play, the tuna fish is off already. And the clownfish is that click is only controlling the clownfish. So getting the children to understand this idea of how many things are nested inside by asking how many things will happen when I click the clownfish, and getting them to notice that there is no black line in between these 2 commands here. So, for example, there is a black line there now, which means they're completely separate. So these are important ideas that they need to notice if they're going to explain or predict what's happening with code. Then the second thing which I think they need to do is you can have code like this, which this is a... I'm just going to try and reset this. This is a debugging activity which crops up in Guard the Castle Knight, and this is aimed at sort of year 3 and 4 children. But in my experience, when we've used this, they have found this really, really quite tricky. And I think this is complex for them because when they look at it, there's just simply a lot going on here, isn't there? And even if I scroll down, there's even more going on down there. There's just so many things flashing. So I think the strategy that children need to use here again is it's again about attention to detail, but it's also about taking one step at a time and just really trying to focus on one block and ignore everything else that's going on. So if we look at this and read it from top to bottom into everyday English, we can see we start off and a character called Knight, who looks to be purple, goes to the right, and another character called Knight 2, who looks yellow, goes to the left. And then we've got a timer that's doing something every second. So we'll scroll down and that's it. There's nothing else that's a sort of main event that's making things happen that's on the left-hand side. So what's the timer making happen every second? And just reading through it. So I'm going to look at this top if block here because that's happening every second, but I'm going to ignore everything below it just for now. If the knight's x coordinate is greater than 15, okay, well that's saying to me if the knight goes too far to the right, then we're going to make something happen. We're going to make night 2 go left. Okay, so I'm just concentrating on this top block here. I'm not getting distracted by anything down here. Night, so again, focusing on it. If night goes too far right, then night 2 goes left. That's not right, so I need to change it so it's night goes left, because otherwise, if one night goes too far to the right, make the other one go left, doesn't make sense. So we've done that. Then I can look at the next one here. If night's x goes less than 5, so if night goes too far to the left, then make the night go right. That's fine, that makes good sense. I'm quite happy with that. Then the next block down says if night 2's x is greater than 15, if it goes too far to the right, then make night go left. So again, we've got this idea, haven't we, of just focusing on one bit at a time. So that's the top tip there. I don't need to finish it, but just my experience of working with children, I found it made a big difference when I just really encourage them to kind of mentally try and blank everything else out that's going on the screen there and just focus on one step at a time. Another example here, this comes from Year 4 coding, and this is an extension. This is an extension of midway through Year 4. There's a lesson which uses an activity called Genie, which introduces variables, and this is the extension activity in this lesson. So again, just how would we read this? Well, again, looking at design mode here, we can see we've got a scene, we've got a sun that's greyed out, sort of hidden in the sky, and not really any other characters going on. So reading through this into everyday language this time, I'm creating a variable, which is going to be a number, and a variable, I might need to remind the children, is just like a storage box that I can put one piece of information into. So I'm storing a number in this box, and the box has got a big label on it that's called day, and I'm putting the value 0 into the box, and that's just setting off my variable. Then the next thing I've got is this timer here that makes something happen every 5 seconds, and I've got no more left-hand blocks which are triggering anything main off here. So I can look into this timer every 5 seconds, and it's saying in here if the value in that box day equals 0, then I'm going to make day. I'm going to take the 0 out and put a 1 inside instead. So I'm just swapping the 0 for the 1. Or else, if day is set to 0, or else set the day to 0. So if there's a 1 in the box, set it back to a 0. Now, I just want to open up something else here, because I did have another. I wanted to show you how you can use a flowchart to help make this make sense as well. Let me just open that up. It's not in there. It's in here. Complexity. Where are you? Flowchart. That's the one. So by making a visual representation of this kind of thing, what I've done is I've just taken this this code here, and I've turned it logically, and you can work through this with the children if it makes sense. So we say start, set the day to 0, and then wait 5 seconds, and then following the only arrow down, it says is the value of day 0? If it is, then set the day to 1. So we're changing the variable in the box, and we carry on round to the wait box, and then we wait 5 seconds and we check again, is the value of day 0? Well, no, this time it's a 1. So we go around the no route and we set it to 0, come back, wait 5 seconds, and then we check again, is the value of day 0? Yes, it is this time. And so we just go around. So it's sort of making a flip-flop, but having this kind of flowchart and maybe writing the zeros and ones on the side. So on here, if you just say, okay, we start off with a 0, and then the first time round the loop, we've changed it to a 1. Oh, and then we go around the loop again and we change it to a 0. So you're building up a picture of what's happening in the program here, going 0, 1, 0, 1. You're helping the children to understand in a visual way what's going on in that program. And when we run the program, another thing that's really good that they can use to help them make sense of it is if they scroll down in this area called variable watch, and there's sometimes quite a lot going on in variable watch. But if you look at the bottom here, you can see there's a variable here called day, and at the moment it equals 0. And then in 5 seconds, it's changed to 1. And then in another 5 seconds, it changes back to 0. And then it's going to change to 1 again. So really all that we've got here is this timer setting off it's triggering an if check, which triggers a change of the value in the box. So again, that's something that can be confusing to them, but I found that if we make a flowchart like this, and it doesn't have to be in 2Chart like this, although it's quite easy to make in 2Chart, but you can draw this just as easily on a whiteboard using a pen. Maybe get the children to help drawing it as well. So I found that helped with helping the children to face a bit of complexity there. So visual representation, and also just that talking it through into everyday English. What does this block here mean? Oh, this means that there's a timer that makes something happen every 5 seconds. Just translating it into everyday English. Maybe in a question and answer session within the class, or maybe just telling them to, could you tell your talk partner or the person on the computer next to you, what does this line here do? Or these 2 blocks, if day equals 0, then day equals set to 1. What's that going to actually do? Explain it to your partner in everyday English. Can be really, really helpful for them, that. And actually, I find just making sure that the children have read the sentence at the top of the screen, because quite often they haven't. Yeah, no, that's a really good point. And that is, like we've been saying, it's that translating code to everyday English, isn't it? Because ultimately, code is another language, and they're learning how to translate to it. Yeah, so thank you. I thought it was worth taking a look at another, perhaps more complex example, and this is something that comes from late on in the Year 5 units. It's the football game. And I just thought we could perhaps finish off with this one as a last example. I think functions, when children get to this, they really need to understand what the purpose of a function is. And the idea of it is it's a job that needs to be done at different times. So the thing about the football one here, which I really like, again, you can go into design mode and you can see there's a goalie here. I think it's gone a bit too far here. Actually, I wanted to stop before this one. But you've got a goal here and you've got a goal here and you've got purple walls around it as well. And the idea is, in this one, that we sometimes want the ball to come back to its starting position. And to do that, we've got this function called reset, which moves the football to its x coordinate of 3, its y coordinate of 8, and its speed to 0. So we're just putting it back to where it started and making it stop moving. But we want that to happen sometimes when the ball collides with a wall. We want to bring it back to the start because we don't want it going off the pitch. But also when somebody scores a goal, it's part of that. So just reading in from the edge here, you've got this one here. When the football collides with the goal, make an applause sound once and get the goals to increase the number of goals by adding 1, and then do that call, do the reset again. So it's the same sort of bit of code here, but it's being recycled. You're using it when you hit the walls, and you're using it again when you score a goal, but you don't have to type it out again. So it's a useful thing, which again, and I think children appreciate that because it's a little bit like, great. So I have to do less work. Like, yeah, you have to do less work. You've only got to write the code once, and then you can make it. You can call it from different places. Oh, I really like that, Mr. Heath. That sounds. Because that appeals to, some of them say, that's really good because I'm quite lazy and I like things like that. And I just always say to them, you're not lazy, you're efficient. Remember that. The word is efficient. But that's another thing. I think that's kind of the highest level of complexity that they get to in Key Stage 2, really. Once they've mastered this idea of things being nested inside other things, like we looked at here, the timer, then the if, and then the command, 1, 2, 3 steps to it. Yeah, the highest level really, I think, is this idea of setting up a job and then calling it from other places. Now, the other things that I thought really with this, so hopefully you saw through here, just getting to know the parts, having a look at design mode, that can help. That's essential for them in understanding code. Otherwise, they don't know what the objects are that they're moving around. Reading the code, left-hand sides of the blocks, I don't think everybody always gets this, that the things on the left are the most important. So this timer here is more important in a way than the if check underneath it and the day than that, because the timer is just going to happen. That is going to happen no matter what, because it's on the left. Things which aren't in that very left column, things which are nested, they're only going to happen when as a result of something else happening. They are dependent. So it's always worth looking at what are the independent actions in here, like the timer or the trout being clicked here, because everything beneath them is dependent. And I think that's a really quite important concept for them to get. And then the attention to detail, and that just is the eternal battle of computers being used for leisure versus computer being used for work, I think, which is part of childhood these days. Taking things one step at a time, and I've tried to use the guard the castles example there, because that they just need to really focus and attention to the detail, one thing, not everything else, and then saying it in everyday English like we discussed. I thought other things, outside of that for helping the children to learn is adapting the plans to meet their needs. So just because it says to do something in the published scheme of work, if I get through one of those and I think, oh, I'm not sure they've got that, I'll make more examples of it and go over it again. Remembering that prim starts with P for predict. So getting them to read and interpret code really is important in terms of how it all starts. Giving more examples if they need it. But something else that I do is I'll screenshot bits and paste them into Word documents. So, for example, I could, if I got a Word document open, I could just say run a screenshot on something. Let's grab a bit of code here. So I'll just pick up this little bit here, and then I'll just paste it into a Word document, and I'll just say explain this in everyday English, and I can set those. I'll sometimes give these to children as morning work. They can do it whilst they're having the register. So it's just literally something like that, and then underneath they have to write what it's doing, translate this into English. I could use that as an assessment, I can use it as morning work, or I can use it as homework through the year to make sure they don't forget. Because if we just do one coding unit each year and then they don't have any more coding experiences until the next year, it's really important to give them things like this in between so that they don't forget it all. So that's another little thing that I think can help them learn as well. So thank you very much for your time in watching this video. I hope that you've found it helpful. Goodbye.